Okay, so this question is on the periodic table. You're likely to get a question on the periodic table during your chemistry paper one. Usually be one question, maybe max about 3 to 4 marks. So it's a good idea to know a bit about the history of it. Sometimes they might ask you to compare the modern periodic table and the current one. Modern periodic table is obviously one that you do have, and they call it on your data sheet, but it's, a data sheet is basically what is there, your periodic table and any equations. You'll be given that in the exam. Okay, so it says give two differences between figure 1, which is the Newlands, John Newlands table, his periodic table, and the modern periodic table. Use the periodic table to help you, so we will be comparing this, and we can see here that in the Newlands one they've put hydrogen in group 1. We don't actually put hydrogen in group 1. They've put fluorine in group 1 here, chlorine in group 1, and we can notice that lithium and sodium, which are in group 2 there, and potassium should be group 1. Okay, so essentially we could say as our two differences that in the Newlands table, group 7 elements are in group 1 on the first column, and then you could say rather than saying group 7 elements, it's best to stick to something like halogens, because then it's clear about what you mean. Okay, so we're going to say the halogens are in the first column, whereas in the modern periodic table they're in group 7. And then here you could say the alkali metals are in column 2. However, in the modern periodic table they are in group 1. You could also mention something like hydrogen is not in group 1 in the modern periodic table or something. So let's have a look. Yeah, so that's fine. You can say Newlands table to distinguish it, but that's fine. Yeah, so we got it there. But we can, if we say if we refer to this table as the Newlands table, it's quite easy to distinguish between the two. Okay, in 1869 Mendeleev produced his periodic table. Mendeleev left gaps in his periodic table for elements that were undiscovered. It's really important how significant Mendeleev's table actually is. It actually predicted a lot of elements that actually weren't there. Rather than just sticking them next to each other, he actually left the gaps. How are elements ordered in a periodic table? They are ordered by atomic number, which is the number of protons, and you can see that clearly on your periodic table. Do not get that mixed up with atomic mass. Atomic number, you can see they're steadily going up by one, but there is a point where I think there's one atomic mass, which I think there are a couple that are like, a couple of elements and they're switched the wrong way or something like that. They're very similar. So No, it's not by atomic mass, it's done by atomic number. Okay, modern periodic table here. Sodium is an alkali and is represented by the letter. All alkalis are in group 1, so it'd be D. An element in group 3 is represented by, well, you'd look in this the third, so this one is group 1, this is group 2, this one is group 3, so you'd represent it using E. A gaseous non-metal element is represented by the letter. Okay, so non-metals are to the right. Okay, and these would be generally like this. And this is a gas. Fluorine up there in group 7, that's a gas. So that would be A. E. Okay, this element is in the shaded group in figure 2. Shaded group being the noble gases. Why is this element unreactive? It has a full outer shell. Yeah, if you do that, if you write it's full outer shell, it's completely stable full outer shell, you will get the mark for it. That's all you need to write. You can see that here. The first electron shell holds a maximum of 2. Second one holds a maximum of 8. So third one also holds a maximum of 8. So when you're having a look at these, you want to be very, very you want to look at them in a very visual way. Okay, those things are the electrons. They go around the atom. The nucleus is in the middle, containing the protons and the neutrons. Protons being positive, neutrons being neutral, electrons are negative. Name the group of elements in the shaded column on figure 2. So yeah, those are the noble gases. So we can have a look at our answers there. Yep. Okay, I'm going to do one more set. Okay, so a sodium atom and a fluorine atom react together to form an ionic compound. Only the outer shell electrons are shown. What is the name of the ionic compound shown in figure 1? Okay, so they're going to end in IDE. Okay, so it'd be sodium fluoride. It's only the last one, non-metal, it changes to IDE. It would be 80 if it contained oxygen. It doesn't contain oxygen, so it's IDE. It changes from fluorine to fluoride. Okay, what type of force acts between ions in an ionic compound? It's known as an electrostatic force. It's well worth committing that to memory. What are 2 properties of ionic compounds? So, ionic compounds, they conduct electricity when molten, and that's important because the ions are free to move. They can't do that when they're solid. And they do have a very high melting point. They do have a very high melting point. Don't think that you put in salt into water, it dissolves, that it's melted. No, their melting point is extremely high. Okay, low boiling point, so that's wrong. Small molecules, that's wrong as well, because if you have a look at sodium chloride, they're giant crystal structures. So, and weak bonds between particles, that's not true. Electrostatic attractions are really strong. Okay, so describe what happens when a sodium atom reacts with a fluorine atom to form an ionic compound. This is the same strategy I taught you last time about answering these type of questions. State what electrons are going from where to where, stating how many electrons there are, using the word transfer. So you would say one electron in a sodium atom is transferred to the fluorine atom, and then you want to say so the sodium ion loses that electron to form a positive ion. The fluorine atom gains that electron to form a fluoride negative ion, and you'd want to finish those off by saying that those the positive and negative ions attract each other. They attract each other, so that's because they're oppositely charged. Okay, so let's have a look. So yeah, sodium loses an electron, fluorine gains electron, a reference to one electron being transferred, and a positive fluorine ion and a negative fluoride ion. So already by that time I've already got 4 of those marks. I didn't even need to say oppositely charged ions are attracted towards each other, or the ions have complete outer shells. I didn't even need to say those because I had said it so comprehensively. So state what loses the electrons, what gains the electrons, how many electrons are being transferred, and use the word transfer. What ions are formed after? So you need to say this forms a positive ion, this forms a negative ion. I mentioned both of them because you can see obviously these ones, this full sentence gets 1 mark. You can't just say this forms a positive ion. You have to mention the whole thing. And what's this one? Figure 2 shows the structure of an ionic compound formed in reaction. Suggest one limitation of using this to show the structure of this compound. Okay, the structure of this compound, there is another method of drawing the structure of this compound that shows like a sort of 3-dimensional shape. This one shows it as a 2D format, so it doesn't show the 3D structure, something like that. Yeah, the diagram is not 3-dimensional. It only shows a 2-dimensional representation, so that would give you the mark.